You know, it is the ultimate cold sweat moment for any engineer. That feeling in the pit of your stomach, a simple command, you look away for just a second and then just silence. You've just done the one thing you're never supposed to do. It's a scenario every single developer has nightmares about, and today we're going to walk through what happens next.
And there it is, delete from users. Maybe you thought you were on staging. Maybe you just forgot the where clause. Honestly, the reason doesn't even matter at this point. The command ran on production. Every single user account, all the customer data they trusted you with, it's just gone. And that heart-pounding realization, it hits you like a ton of bricks.
Okay, your career is flashing before your eyes. The entire business just ground to a halt because of a command you ran. Panic is setting in. But what you do in these next few minutes, right now, is going to determine whether this is just a recoverable incident or a full-on company-ending catastrophe. So, what's your first move? What do you do?
Now, the first instinct for almost everyone is restore the nightly backup, right? It sounds so logical, so simple. And look, for some small internal systems, maybe that's fine. But in a real high-scale production environment, it is a fundamentally flawed, almost amateur approach. Let's break down exactly why.
This timeline right here shows you the whole problem. Your last backup was way back at 10 p.m. last night. The disaster, your little delete query, happened at 3 p.m. the next day. That leaves a 17-hour gap. And inside that gap is every new customer who signed up, every order placed, every single critical transaction, all of it, gone, forever. This gap, this is what we call your recovery point objective, or RPO. And a 17-hour RPO, that's a business-ending failure.
So here's the real trade-off, laid out plain and simple. A nightly backup strategy means you accept data loss measured in hours, sometimes even a full day. The impact on your customers is absolutely catastrophic. You lose their trust, you lose their business. The goal, the professional standard, is point-in-time recovery. Here, your data loss, your RPO, is measured in seconds. The impact becomes minimal. Most of the time, your customers won't even know anything went wrong.
But you know, an even better approach than having a fantastic recovery plan is not needing one in the first place. This is where you see the difference between a junior and a senior engineer. Senior engineers know that people make mistakes. We all do. The goal isn't to be perfect, it's to build systems that are resilient to our own imperfections. It's about architecting to prevent the disaster from ever happening.
And the foundational concept for this is something called the principle of least privilege. It's actually a pretty simple idea. It just means you give a user or a service only the exact permissions needed to do its job, and absolutely nothing more. So in our delete scenario, did the engineer who ran that query really need permission to delete the entire table? Probably not. They probably just needed to read from it. That's the gap this principle is designed to close.
This quote just puts it all into perspective, doesn't it? You would never, ever hand out a physical master key to every single person in an office building. I mean, it's obviously a huge security risk. And yet, in our digital world, we hand out the equivalent, unrestricted, God mode database access all the time, without even blinking.
80%. Just let that number sink in for a second. This single number is at the very heart of why most security failures happen. Let's dig into what it actually represents.
And there you have it. According to Forrester Research, a staggering 80% of all security breaches involve the misuse of privileged credentials. Our accidental delete command is a perfect textbook example. The root cause wasn't some evil hacker. It was a well-meaning engineer who had permissions they should never have had in the first place. So, okay, prevention is the ideal. It's layer one. But we have to build systems for reality, not just for the ideal world. So let's assume prevention failed. The disaster happened. A world-class recovery isn't just about some magic technology. No, it's a combination of the right tools and a well-rehearsed human process.
The key piece of tech here is the database's transaction log, sometimes called a redo log or a write-ahead log. The best way to think about it is like the black box flight recorder on an airplane. Every single change, every insert, update, and delete is written down in this log first. It's a continuous second-by-second history of everything that's ever happened to your data.
So, how do we use this thing to turn back time? It's a pretty straightforward three-step process. First, you restore the last full backup. Yep, the one from 10 p.m. last night. That's your starting point. Second, you dive into those logs and find the exact transaction ID right before your fatal delete query. Finally, you just replay all those transactions from the redo log one by one right up until you hit that last safe point. And boom, Your database is restored to the exact millisecond before the disaster.
But here's the thing. Having the world's greatest recovery tool is completely and utterly useless if, in the middle of a crisis, nobody knows who's supposed to use it, or when to use it, or who they need to call. When panic sets in, chaos can derail any purely technical solution. And that's where process becomes absolutely critical.
A mature organization has a formal disaster recovery plan, or a DRP. This isn't just a document, it's a playbook. And it defines very clear roles. You've got an emergency response team to figure out how bad things are and sound the alarm. You've got a disaster recovery team. These are your technical folks who actually do the restore. And then you have a business recovery team to handle all the communication with customers and stakeholders. Nobody is standing around wondering what to do.
And this, right here, is the part that so many people get wrong. A plan is just a piece of paper until you practice it. The reason successful DRPs work isn't because the document is perfect, it's because people have run drills. They've simulated disasters. So when the real thing happens, it's just muscle memory. They're not reading a manual for the first time in the middle of a fire. They're executing a playbook they already know by heart.
All right, let's put all these pieces together into a complete professional solution. See, it's not about choosing one strategy over another. The real answer is to build a defense in layers, where each layer is there to catch you if the one before it fails.
So this is how it all fits together. Think of it as 3 layers of protection. You start with the people layer. Your strategy there is prevention. And the key concept is the principle of least privilege. Stop the mistake before it even happens. But if that fails, your technology layer kicks in. The strategy is technical recovery, and the key concept is point-in-time recovery using those redo logs. And finally, if all else fails, your process layer ensures an organizational recovery using a well-rehearsed disaster recovery plan. They all work together.
So, the most important thing to take away from all of this is really a fundamental shift in how you think about these problems. It's a new mental model for how senior architects approach system resilience.
Here it is. Don't just plan to recover from failure. Architect to prevent it. See, the goal isn't just to get really good at cleaning up messes. The goal is to design systems where those kinds of catastrophic messes are far less likely and far less damaging in the first place. So the question you should be asking yourself isn't how fast can we recover, but how many unnecessary master keys are floating around our system right now.